All right, welcome everybody. We are actually going to start our first stuff with science content today. We're going to be talking, this is in our unit about Earth's systems. So the very first thing we're going to talk about is water. We won't really get into the water cycle since you guys do that so much in middle school, but we are going to talk about the properties of water and how it's important to our Earth. Okay, now, that being said, if you have not listened to my first intro video or done the first initial assignment where you just submit me a blank document, make sure that you go back and do that. We all need to be on the same page as far as submitting assignments and that sort of thing. So make sure that you do that. I had some people email me their document. Make sure you're not emailing me the document, you're submitting it to the assignment on Teams. And the reason for that is I just don't want 75 emails from all my students every time I assign something. Okay, so moving on, okay, we're going to talk about water today. So let's look at the properties we're going to talk about. Okay, so first up, we have high specific heat. Okay, so that's number one. Okay, by the way, in case you're wondering, yes, you should be taking notes. Okay, obviously, we are going to be having some kind of check that you are watching these and that you are, um, going through this stuff and making sure that you're learning the stuff that you need to learn. Whether I haven't decided on whether I'm going to have you take pictures of your notes for your binder checks or what I'm going to do as far as that. But make sure that you have a piece of paper out right now and you are taking notes. Okay, there's not a lot. Okay, so just get them done. All right, but the first one we're going to talk about is specific heat. Okay, then we're going to talk about how water is a universal solvent. Next is its cohesion, adhesion, and finally its density. Okay, so let's get into high specific heat. All right, so specific heat, let's first define it. Okay, so make sure you write this definition down. Okay, you can pause and restart this video as many times as you want. It's not going to make any difference to anybody else. So, high specific heat. The specific heat is the heat required to raise the temperature of a specific mass of a substance by a given amount. Okay, so these readings down here at the bottom are in joules. That is the energy required to raise their temperature 1 degree Celsius. Okay, so that's what we're talking about as far as specific heat. It's the amount of energy or heat required to raise the temperature by a given amount. Okay, so what does that mean? So things that have low specific heat, okay, the temperature of that substance is easily changed. Okay, so for example, like concrete. Okay, concrete is really, really cold. Okay, really, really cold when it's cold outside. It's really, really hot when it's hot outside. Okay, it varies in its temperature a lot. The other examples I have on here are metals. Okay, metals can be really cold. Metals can be really hot. Okay, rocks of all kinds can get really cold and they can also get really hot. Now, when we talk about high specific heat, okay, that means that the temperature is not easily changed. Okay, the things that fit into this category are like the insulation in your attic. Okay, obviously you want them to be pretty insulated so that they don't change their temperature very much. Okay, if it's cold outside, you don't want them to change very much. If it's hot outside, you still don't want them to change very much. And then of course what we're talking about is water. Okay, water has high specific heat, meaning that it's really, really difficult to change the temperature of water. It requires a lot of energy. Okay, so how this affects places and things. Okay, right now up here on the graph I have the different temperature averages for the months in Seattle and for the months in Denver. As you imagine, Seattle is right next to the Pacific Ocean. Okay, so a lot of water in the atmosphere, a lot of water near Seattle. And you'll notice, okay, that it has these temperatures that only range from 47 as a high to 72 as a high. Okay, not very much temperature change between those, even in the middle of July and August when we typically have our hottest months in the summer. Okay, you'll also notice that their lows are not that much different than their highs. Okay, again, that has to do with the fact that they're near water and it's really difficult to change the temperature of water. Okay, whereas if you look at Denver, look at the difference between January and July. Okay, it goes all the way from 49 degrees as a high to 92 as a high. Okay, and these are all averages. Again, obviously we get hotter sometimes than 92, but on average, okay, these are what they look like. So it ranges a lot more than from 47 to 72. Okay, you'll also see there's a huge discrepancy between the highs and the lows in given months. Okay, again, because Denver is not surrounded by water, it's easy to change the temperature in Denver. All right, moving on to universal solvent. Water is a molecule. You guys probably know it's H2O. Okay, 2 hydrogen and 1 oxygen. Okay, atoms in water. Let me move my face. Atoms in water bonded by sharing electrons. Okay, so they bond to each other. Okay, really what we're talking about here is that water likes to dissolve things. That's what this solvent piece is about. Okay, solvent. It likes to dissolve most of the materials in our world. Okay, the oxygen is stronger in the bond than the hydrogen because obviously hydrogen is a lot smaller. Okay, so it has a lot less pull. Oxygen holds the electrons more tightly towards itself than it does the hydrogen. Okay, it's slightly negative. Okay, so it's pulling all the positives close to it and repelling all the other negatives. Hydrogen doesn't attract electrons as well. It's actually really bad at attracting electrons because it's not very big. It doesn't have very much charge. Okay, so hydrogen is slightly positive, mostly because it only has 1 electron. Okay, so it doesn't have a whole lot of negative charge. Okay, partial charges allow things to dissolve easily in water. Okay, so these combinations of positives and negatives, so we have these 2 positive hydrogens and these slightly negative oxygens allow things to dissolve easily in water. Okay, for example, we dissolve salt and we get salt water. Okay, you can dissolve sugar and you get sugar water. Okay, all those things dissolve easily in water. Okay. There are lots of things in rock that water likes to dissolve as well. If anybody has ever been to limestone caves, they're actually pretty cool. If you want to look them up, go for it. Yeah, but they look like these off to this picture off to the right, where the water has pretty much eaten away all of the limestone inside there, and you can literally walk right in and see all the different deposits. Okay, it also likes to dissolve ions in rocks to make mineral water. That's where we get all these pure mineral water bottles and that sort of thing, which of course everybody's buying up right now for whatever reason. All right, so let's talk cohesion and adhesion. Very similar concepts, but they mean 2 different things. Okay, so you're gonna have to keep them straight. So make sure that in your notes that you're keeping track of which one is which. So hydrogen makes a temporary attraction to other oxygens in water molecules. So if you imagine a glass of water has a lot of water molecules. So in the microscopic level, if you look at the hydrogen, it is slightly attracted to the other oxygens around it, not just the one that it's bonded to. Okay, so we have other oxygens and other hydrogens, and the hydrogens are attracted to oxygens and the oxygens are attracted to hydrogens. Okay, they form what we call hydrogen bonds, which are just momentary attractions. Okay, momentary attractions. So if you imagine, let me see if I can take my pen. There's another oxygen over here, and maybe another one over here, that these 2 hydrogens are attracted to. Okay, so there's some form of attraction going that way as well. Okay, let me put an O in here if I can. I don't have my pen, I'm using literally just my touchpad. Okay, but either way, so there's this momentary attraction between those and other water molecules. Okay, so if you imagine this isn't just an oxygen, it also has its own hydrogens that are connected out here. Okay, but they reorient themselves so that the oxygen is attracted to the other hydrogens. Okay, so cohesion forms hydrogen bonds with other molecules. Okay, so hydrogen bonds connect water molecules to other water molecules to other water molecules, and so on and so forth. Okay, adhesion forms these hydrogen bonds with other molecules. So if water is being introduced to something else, okay, anything else, okay, the water also binds to it. Okay, so water not only binds to itself, so when it binds to itself, that's cohesion. Okay, when it bonds to something else, that's adhesion. So make sure you write that down. Okay, cohesion is water bonding to itself. Adhesion is water bonding to something else. All right, so what are the results of this cohesion and adhesion? So for cohesion, this is why we have surface tension in water. Okay, that's why when you jump off of something and do a belly flop, that it literally hurts. Okay, it hurts because of the cohesion between the water molecules that make water slightly hard on the surface. Okay, so those water molecules on the surface of the water are bonded together. If they weren't, okay, there would be almost no impact. You just simply slip right through the water and there would be no big splash or anything like that. Okay, water abrasion. Okay, so this is like where water is hitting rocks on the on this coast right here and it's slowly eroding that rock away. Okay, so obviously the water has some kind of hardness to it in order to do that. Okay. So, density. Cohesion is water attracting to water. We already said that. Okay. Adhesion is bonding to something else. I forgot to say this in the last slide, but water bonding to something else is kind of like if you had a cup of water, okay, if you had a cup of water and you dipped a piece of a paper towel just barely in it, the water would literally climb up that paper towel. That's adhesion, okay? Because it's bonding to a different substance, okay? It's bonding to something else other than water. Okay, so in liquid, hydrogen bonds switch and bounce around, okay? Kind of like this image right here. Okay, let me get white. Okay, this one. Okay, they bounce around. They're going kind of not all structured. And then if it's a solid, okay, and for us, a solid water is obviously ice, it's very structured. Okay, and notice how they're evenly spread out. Okay, and what I want you to think about is which one is more dense. Okay, and this means that they're packed together and not spread out. Okay, so in fact, in case you were wondering, okay, the ice is actually less dense. Okay, this is why ice floats in most of the liquids that you put in it. Okay, so for example, if you get a glass of ice water, the ice is going to float to the top because it's less dense. Okay, the molecules in it are spaced out more. Okay, it actually expands more. This is why, okay, ice is dangerous for pipes in the winter when they get cold because water expands when it freezes. Okay, so if it expands, it's going to burst pipes. Okay, so it's less dense because it expands. All right, so to sum up everything that we talked about, okay, water has high specific heat, meaning that it's difficult to change its temperature. It's a universal solvent, which means that it likes to dissolve things based on its molecular makeup, okay, things like salt and sugar and things like that. Cohesion, it bonds to itself using hydrogen bonds. This is what makes the surface of water hard. Okay. Adhesion, it also forms hydrogen bonds with other molecules. This is what makes water travel up paper towels. And lastly, we have density, okay, which causes differences in the molecular makeup. Okay, when it's a liquid, they're more dense, so the molecules are packed closer together. When they're frozen, they are less dense, they expand, and they tend to float. Okay, that is it for water. Make sure that you guys finish your assignments that go along with this. It's just going to be an article I want you to read and some questions I want you to answer. Make sure again that you upload those to Teams and you do not email them to me. If you email them to me, I'm going to respond and say, hey, upload this to Teams, please. And then there's a check for understanding. And then there's also going to be a form, okay, a Microsoft form that I want you to fill out just to check to make sure that you actually watched this video. All right, well, thanks for stopping by, and I will see you next time. Remember to email me or contact me in any way. People have been texting me just on Remind. It's really easy. I just get it straight to my phone and I get to message you right back almost immediately. So if you want to do it that way, that's fine. If you want to chat on Teams, that's fine. Any way you want to get a hold of me, I'm here. All right, we'll see you guys later.